So I'm sorry I can't be with you today. Today I want you to work on the factor theorem. So the factor theorem builds directly out of the remainder theorem. Right? In the remainder theorem, we understood that if we had a polynomial and we were dividing it by a linear equation, okay, something that looked like x minus a, then we could find the remainder by simply substituting in the a into every position of where the x was, and we'd get a remainder. Now, the factor theorem says that when I do that, when I use that remainder theorem and I substitute in a value, if I get a result of 0, then this x minus a must be a factor of the original polynomial. I guess what we want to do is we want to understand why it's important to use the remainder theorem. And why would I use it? And how would I use it? Okay. So I'll just sort of step it out and I'll read this out. Hopefully it makes sense. Remember that once a polynomial is divided, we know the divisor and quotient are factors if there is no remainder. Okay, so if I start with a polynomial and I divide it by something and I get a quotient but there's no remainder, then the divisor and the quotient must both be factors of the original polynomial. Okay, when we did quadratics, okay, the whole point, or one of the main reasons of taking standard form and factorising it was to get factored form. Okay, and when we got factored form, we understood that each of those factors helped us find the roots. Okay, so because polynomials are just an extension of quadratics, if we can find a divisor that ends up with no remainder, okay, by trialling some different numbers, we can then shortcut our process to finding factors. So, for example, if I was to trial the polynomial by substituting 1 into all the x positions, and if I got an answer of 0, okay, then I know that x subtract 1 is a factor of the polynomial that I started with, all right? And then I could divide it to find the other factors, all right? If P1 wasn't 0, I kept doing some trials and then I substituted in P of -2 and I did find that that equaled 0, then I would say, oh, okay, well, x plus 2 is a factor. So remember there's that relationship. If this is a negative, then this will be a positive. If this is a positive, then this will be a negative. Okay, so that's an important relationship we don't want to overlook. I'm going to stop this video and I'm going to start a new one with an example.